getting you and welcoming you all here. Talking a little bit about the 7 exciting weeks, what had all to come, what was necessary to come together to make it possible, what Hack4Good is actually about. Then, and that's probably why you're all here, we're having the team pitches where the approaches and data science problems, challenges that the students were facing and the nonprofit sector partners were facing are going to be presented. And there you'll have the time to also ask the teams about their experiences and their problems, and maybe also develop ideas how other problems could be solved in a similar vein. Then I'll very shortly talk about what is next in Hack4Good, or how the student participants or guests from other nonprofits or can interact with us in the future. And then a very exciting part I'm really looking forward to is the digital apro, where we are going to go to Wonderme, which is a very interactive tool that we can make a meet and greet possible despite the online setting. So why Hack4Good in the first place? People at the Analytics Club now 3 years ago or 3 editions ago had the conclusion that data science can not only be used to give you the best marketing or maybe make your car self-driving, but have a more important social impact and can also work towards a more sustainable world. And based on the 3 principles of the Analytics Club, which is learn, connect, execute, the initiative was founded. By learn, we mean that the students, the participants have the opportunity to get hands-on real data and work with the problems that NGOs and nonprofit organizations face in their real time. We offer workshops that facilitate them to do so. For example, an exciting pitch workshop, impact workshop, technical workshop, and also on agile working to function better as a team. Then we connect. The students and the partner organizations have the possibility to have weekly or how often they need the meetings to actually understand the problems and discuss their solutions. And then execute, possibly that's what's happening today, really show that these solutions that are developed can be applied to the practice and can be transferred to the organization, and facilitate this to happen will actually be the challenge of the next week, doing the code handover. So I was talking a lot about challenges already, and this would not be possible to address the challenges if the GIZ, Helvetas, Impact, IDMC, and Rega had data and questions to that data that the company internally had difficulties to solve. So they cooperated with us before this project even started to shape the ideas and actually scope them in a way that we have the data, we have the question, and we have a possible framing to address this problem in 7 to 8 weeks. And I would really like to thank these organizations for putting so much time before the event and during the event to interact with us. And yeah, you can click the clap symbol if you feel like it. I will move on to the next slide, because in addition to the nonprofit partners, there were also organizers that worked beside their studies on making this event possible, and invested a lot of time to have the events going, have the contacts, and have the project scoping even again before the event started. And a big shout out also to our mentors, who are experienced data scientists from the industry, who should guide the students in this transfer from the theoretical knowledge they have to actually building company or organization targeted solutions that can also be used possibly by non-tech people that are not from the technical side, that don't have their focus on technical expertise. And then after this all came together, we had problems And now we needed a lot of students to actually put in a lot of time, a lot of motivation, and solve these problems or find their approaches to it. And I really want to thank all of you as well, the participants. You'll get to know them in a little more detail in a second, for investing this time and coming up with the solutions that are now going to present it. 1 second before that, however, I really wanted to give a good overview about the program. However, I realized that it's a little hard if you not have been there and seen all the struggles, but also the excitement, the nice events, the fun we had, despite most of the events were online. And I think the most accurate view I can give you is by showing and sharing this video with a few impressions. So the participants can recap and our guests can actually see how the solutions that are going to be presented in a second came to be.
We like to develop first a very strong
to implement the data pipelines and to help the NGOs, no matter in regardless of their expertise in data analytics, that they can make good use of the models that we build and to understand the data better. Let's get it done, right?
So, do we need this planet?
Okay, are you an ETA student? Are you frustrated by the low temperatures country in winter?
Our lives are like packed with appointments, and I'm sure that you know the feeling that your calendar is really full.
Then I may have just the product that you need.
Okay, so this is the Swiss Army knife.
And this is bee ointment, not just any ointment.
In my room is my thermos bottle because it keeps you warm on a cold day. And
so an Nalgene is the best bottle or the best way to stay healthy and hydrated.
However, there's a simple solution. It is called alarm clock.
And it smells wonderful. You can almost smell it back there in the room, right? And
so my solution is that everyday solution is my PC.
And you can take it anywhere. You can take it for a hike, you can take it for a date, you can take it for the Hack4Good hack days. And with this, you won't feel hungry anymore.
So be sure to to check out this amazing product. Yeah.
And I think that was the perfect statement there at the end to lead over to the first presentation of the team working together with Impact Initiative. Check out this amazing product. You'll have 10 minutes for the presentation, and I'll give a small indicator when 9 minutes are over, and then we'll open the floor for question. So check out this amazing product.
Shall I share my screen?
Yes, please. I stop mine first.
Okay, can everybody see it?
Yes.
Yes. Perfect.
Can I start?
Sure, go ahead.
Okay. So good evening. We are the Impact team. We are working for 7 weeks with the NGO Impact Initiative on the topic of falsified data detection in surveys of households in crisis regions. So our team is made of master students from ETH and UZH. So we have Romina, Barbara, Siran, and me, Julie. And in this little pitch, we will present to you how to boost your data quality with intelligent fake detection.
Impact Initiatives is focused on development action through data. Generally, we can categorize what Impact does into 4 sections. First, it conducts field-based assessments and research projects to inform planning, programming, and implementation of humanitarian and development projects. In order to be able to distribute humanitarian resources, they need to gather data. In our case, these data are collected as surveys and questionnaires from local people and households. Second is monitoring and evaluation of humanitarian and development interventions to support aid actors in assessing efficiency of their programs. Third is to produce information management solution to facilitate this decision-making by aid actors. And fourth and finally is to facilitate organizational capacity building programs which supports local and international aid actors to understand, plan for, and absolutely respond to crisis. As mentioned, the goal is to distribute humanitarian aid and resources. They need accurate and reliable data to do so. These data are in the forms of surveys and questionnaires from local people and households. Some regions in these countries, in our case is Afghanistan, are hard to reach, and Impact has to rely on third parties and collaborators to conduct these surveys and gather information. Some of these surveys are intentionally falsified or just not accurate enough. They cannot make proper decisions based on these data. Falsified data inhibits proper action. They need large post-processing efforts to clean these data. Part of these processes are automated, but still it requires a lot of human intervention to identify falsified data. So there is no ground truth labels, but there are some experts who annotate these surveys as falsified manually.
So the problem is that labeling interviews as falsified or as clean is by large part done by human intervention and only partly automated. This is because labeling interviews into clean or falsified is not only depending on some single responses, but it's also often depending on a combination of responses. And for this, the data cleaner has to check if the response combination as a whole makes sense. Therefore, the current labeling process is very time-consuming for the MPO, and an automation based on such heuristics is not scalable. Now, the goal of this project is to develop a tool for detecting falsified data in surveys and to speed up the labeling process by making our algorithm point out potentially falsified data points in the survey. And there is a preference to minimize the risk of classifying fake data as clean data, even if this goes at the expense of classifying more actual clean data as falsified. So our approach is to find falsified interviews with a classifier model, and we named it Classifals. So the model identifies potentially falsified data points in surveys, and here you can see a very simplified illustration of the survey data set used and how our solution looks like. So each row is one interview for one household, and there are many multiple questions in each interview. And our model labels each of these interviews in a survey as either clean or falsified. So the MPO can then double check those interviews, classified as falsified, and they don't have to manually look at the whole data set instead. And as a final model, we used XGBoost classifier. This is an ensemble classifier, and you can, for those who don't know what this is, you can imagine it like a combination of multiple decision trees. Since this algorithm belongs to supervised machine learning, we had to use labeled data as input, as Romina has already told you, and this was kindly provided by Impact. And we also had to do some data cleaning, removing redundant columns, dealing with missing values, such that we would not lose any information. and we created new, more meaningful features out of the given columns.
So our data set contains all the household interviews conducted in Afghanistan in 2019. As you see before, it's a tabular data set where each row is an interview and each column corresponds to the answer to a question. The question answers are usually yes or no or numerical values. And we have in total more than 40,000 interviews consisting of 619 questions. What we do first is labeling the dataset. As mentioned before, Impact did some preliminary data inspection manually so that some suspicious interviews are identified. We labeled them as falsified data. And for the rest, we labeled them as true and clean data. Around 25% interviews are considered falsified. So by making use of this work from Impact, we get a labeled dataset, which is very valuable because it can be used for supervised learning. We then cleaned the data by correcting some formatting problems and removing columns that are redundant or irrelevant to our tasks. Besides, there are about 37% missing values, and we used some algorithms to fill these empty cells in the table so that our model can handle the dataset. Last but not least, we create some new features about the enumerator and interviews behaviors, which may be predictive for falsification.
Finally, let's have a look at our results. So given a certain data set, our algorithm will predict for each interview if it's falsified or not. So we compare the results from our algorithm to the input from impact initiatives and find that 87% of the interviews were correctly classified by the algorithm. So it means that only 30% have been misclassified and half of them were clean interviews classified as falsified and the other half were falsified interviews classified as clean. We can have a closer look now at how the algorithm practically detected falsified data. So some questions were way more important for this decision than others. For example, the interview duration or the number of missing values were valuable information for the model. And the algorithm defines some boundaries and rules to decide if the input is falsified or not. For example, if the duration was under 35 minutes and the day of the year was before the day number 219, then the interview would be classified as falsified. And if the duration was over 61 minutes and we didn't have any information about the household head, then also this interview would be classified as falsified. This is actual rules from our model, but simplified here.
As a summary to our findings, our approach can be used to save effort and time. As a use case, the model could be integrated into the existing data cleaning and labeling process of the MPO and be used to find potentially falsified interviews in new incoming interviews. Now, in the final application of this model, it can be defined how large is a tolerance for missing potentially falsified interviews in the survey. So the currently best result with missing as least falsified data as possible is that we save around 40% human cleaning time while missing less than 2% of falsified interviews. So less than 2% are not detected. And in the future, the model can also be applied to new surveys, and robustness and performance can still be enhanced by retraining the model on more data with additional labels in the future.
Thank you for attention. We can have a Q&A session now.
All right, thanks a lot for the presentation. So then over to questions. If somebody already has a question, you can just unmute and ask it verbally. Otherwise, there's also already one in the chat that I could read if you still need some time to think.
I asked the question, David. Hi, it's Naina from Impact.
Sure.
I mean, I can wait. I see Simon has.
No, go ahead.
My question is, I think we already discussed this a couple of weeks ago with the team, but just in terms of further application and yeah, what type of like labeling would it be if we had a similar data set to what you built this tool on? Like what kind of preparation steps will be needed by future users of the tool, essentially? Does that make sense?
So your question is if we had the same data set, but in next year, another data set?
Similar, but not identical.
Yes, so we did some feature engineering and cleaning. So it would be good if you could apply this on your data set. And if you don't have the same answers, you would have to check if how important these features were for detecting this falsification. And you would have to modify that in your data set. And it really depends on what it looks like.
Okay.
So the thing is, we have been thinking that maybe the pattern in general of falsification is not so very different across many different regions, because the motivation is usually pretty similar. But of course, if you have different questions in an interview, then we would have to modify that so that it's applicable, because you don't have the same features then.
Yeah, okay, clear, thank you.
But we can discuss this in more detail later in the meeting.
Yeah, there's basically a debriefing planned, Nayana, so you'll have some time with the team as well. Just one,
okay.
Four on one, so to speak.
Great, thank you.
Thanks for the question. Then there's two questions in the chat. So Simon asks, and I quote, do you have an idea of what peculiar, I can't pronounce that, like what makes it peculiar that of the data caused the false positives? So the wrongly falsified interviews. And like he's basically just asking how those samples differed, or if you've looked into that. Does that make sense?
Simon, do you mean what kind of indicators were often leading to the fact that this data was then classified? No.
Maybe I can ask the question in person. So the question essentially is, for the ones in your confusion matrix that were wrongly labeled as falsified, do you have an idea of why that happened? That would be very interesting for me, essentially, to hear.
We didn't really look at it because we have a lot of features, and actually the rules are way more complicated than the one I said earlier. So I think you can't really, like, maybe if you look at all the feature, you could understand why it has been misclassified. But as we have more than 1,000 features, it's a bit hard to really understand why it has been misclassified. I don't know if the other want to say something.
Yes, I agree. And we implemented some interpretable tools and tried to have some local interpretation for each example, that why this example classified as falsified or not. But this is actually example specific, so it's not a general rule.
Okay, so there was no general trend that was consistent over the different examples that you looked at?
We couldn't find any so far, but
Okay, thanks. Then there was a question by Julian. Do you want to unmute and pose your question? If not, I can also pose it for you. Okay, you're in public transport. Okay, then I'll ask the question. So he's just asking. So he's curious if you know kind of why day of year has such a large impact for the model, or why the future importance of day of year was so high.
We have several guesses. So maybe because sometimes it was during holidays. So I mean, like, no, not holidays, but maybe a day of work. So it was harder to reach to people. And so that's why maybe this day was considered as a day where people were more falsify more the data. or maybe because it was just before the deadline. So if someone didn't answer, like did all the interviews, then he will falsify the data because he doesn't have the time to reach to people anymore or thing like that. We don't have any real explanation.
Okay,
Maybe
great.
Yeah.
Yeah, looks like that answered it. Yeah, thanks. Then I see that Michael has raised hand as well. Do you want to ask a question? If so, feel free to just unmute.
Yeah, thanks. Yeah, thanks for the presentation. Very interesting and very exciting work. I have just two questions. One clarifying question and the other out of curiosity. So the first one is, did I get the objective right that you assumed that some of the 40,000 questions were just deliberately put like as fake? So it was the exercise was not so much about finding wrong entries in one observation, but rather to drop the whole interview or not. So it's not about inaccuracies when it comes to answering certain questions, but rather the question was the whole interview made up or not? And I hope I did get this right. And the second one is more about the missing value imputation, and just to get an idea how you did it. What is it that you had these missing values and you came up with rules, or kind of what usually you could put in such an observation, maybe regarding to the other observations you had, or what was the model behind the missing value imputation? Thanks.
Yeah, regarding your first questions, yeah, you were right. So the problem was to detecting the whole interview is valid or not the individual cells or questions. And I believe for your second question, Julie could explain it better than me.
Okay, so for the missing values, a lot were from categorical variables. So we used dummy encoding with like a column for the non-values and for numerical. So we tried some classical imputation with like random forest and everything, but we had too many missing values, so it was not working. So what we did was we tried to understand what was actually the feature, what was the meaning of the feature, and what was the meaning of missing values. What was it non-applicable or more missing? So we imputed with 0 or median, depending on what made sense. For example, if the question was about a pregnant woman and it wasn't applicable because there wasn't any pregnant woman in the household, then we put a 0. But if it was more about income, then we put the median value, and we add another column for each column, like a validation column with 0 if the value was missing, and 1 if the value was not missing. This way, we could keep a track of which values were missing and which values were not. And so we used XGBoost as an algorithm because it could handle missing values. And with this algorithm, we could compare the results with the imputed dataset and the dataset with the missing values in order to check if we weren't introducing any bias or something. And so we weren't, so we keep this method. Yeah.
Okay, thanks for all the questions and the answers of the teams. We have to, time-wise, but also I think there are other people who are really excited to present. The next team that I would like to ask to present is the GIZ team. Yeah, there they are.
Okay, I will start then. Good evening, everyone. Today we will learn how data science can help to stabilize the food supply in rural Zambia by identifying important drivers of crop production. Sorry, next slide. The agricultural sector is important for food security and economic growth. This is the case for any country, but this is especially true for Zambia, where over half of the people are reliant on farming as the main source of income. Despite such a large share of the population being employed in agriculture, the farming only accounts for less than 10% of the total GDP. In addition, because of an increased frequency of extreme weather events such as floods and droughts, farmers increasingly struggle to produce a steady supply of food. This has dramatic consequences. Malnutrition caused by this insecurity in supply poses a serious problem. 34% of children suffer from health consequences caused by a lack of food. GIZ and their partner Komako aim to mitigate some of these issues by tackling the key constraints to increasing crop productivity and income to the farmers. These efforts include regular training of farmers conducted on-site and over radio, which is aimed at increasing the knowledge of the farmers about effective farming practices. Another focus lies on the advancement of new value chains to diversify the agricultural production. This includes the introduction of new cash crops such as soy or groundnut, which can help to diversify the income and the risk of farmers. These efforts have been conducted for several years over an area in eastern Zambia, and we can see some of those farms on this map. But this poses a question: what can we identify interventions that are especially useful? To answer this question, there needs to be a data-driven approach with a detailed analysis of time. So first we have a look at the productivity data collected by GIZ between 2016 and 2019 on the left. This is for soy in this example. We can see large variations in productivity between each year, but also find that the distribution varies noticeably between years. Now, what factors might be responsible for this variation? First, there are external factors, such as weather during the growing season or the soil type where the crop was grown on. Such factors also include extreme weather events such as flash floods or dry spells. One can easily imagine such events having a detrimental effect on the harvest. Second, there are internal factors. These include the farmers themselves and their households. For example, the level of education and the training varies across the population. So decisions on the farming process themselves, such as timing, the timing to sow seeds, or if fertilizer is going to be used, varies depending on which farmers. It is therefore the goal of this project to quantify the effects of both those internal and external factors on crop productivity.
Well, and how do we do that? Together with GIZ, we identified 3 main sources of information. The first is the weather. Temperature and precipitation are crucial for the growing of a crop. We retrieved detailed weather data from ERA 5, such as the amount of rain on a particular day or the maximal temperature. Also, we engineered some features, such as whether there was a flash flood or whether there was a drought. Beyond the weather, there's a second factor that influences agricultural productivity. It is the direct surrounding of a crop, namely the soil. From a company called SoilGrid, we retrieved rich and detailed information about several soil properties at certain GPS locations. A prominent example would be the nitrogen amount in the soil or the proportion of sand in it. Having analyzed these datasets, we found that they indeed show a significant regional variation. Further, the weather data revealed large differences over the years. And all these factors might contribute to explaining the variation in agricultural productivity. It helps to understand under which circumstances the farmers needed to operate. However, even though these factors show a large regional variation, they do not fully explain the variation in agricultural productivity. You might wonder how we can be so sure about that. But take a look at that box plot. It shows the distribution of agricultural productivity in Zambia for groundnuts for different villages. And what is especially noticeable is that the variation is huge inside a village. The external factors for each village are roughly the same, so they do not explain the variation inside a village. Why did some farms suffer from too much rain and others didn't? Questions like this cannot be answered with external data. For this, we need information of the farms and the farmers' practices. This brings us to the next data source we analyzed. GIZ conducted surveys with some farmers in eastern Zambia and asked questions about their fields and the days they worked on the farm and about whether they participated in trainings and all such things. And even more important, these questionnaires also contained our target variable, the land productivity. But probably the first lesson that every data scientist needs to learn when stepping out of university, almost no real data set is as clean and ready to use as we see them there. And the same applies here. Each questionnaire had a different structure. Not even the shared variables were named equally. With a lot manual effort, we combined the questionnaires over the years. However, the combined questionnaire was only the smallest intersection of all the 4 years, meaning that we lost a substantial amount of detail along the way. With these features only, we were unfortunately not able to model the variation inside the villages. And we also tried to focus on 1 year only, which allowed us to use all the details, but drastically reduced the sample size. And this also meant that we wouldn't be able to analyze the differences over time. So we concluded from that if one wants to analyze this data over time, then it needs to be ensured that the questionnaires are standardized so that they can be combined without loss of information. And secondly, there's another issue that makes an exact modeling even more difficult. It seems fairly easy to measure one's land productivity. You just weight your harvest and then divide it by the size of your fields. But in practice, it's not that easy. Farmers in eastern Zambia do not necessarily have the means to exactly measure everything. And it is definitely also not their highest priority, which is totally understandable. But for us, this means that there's a large uncertainty in the target variable. We saw this as we noticed that around 10% of the yields were unrealistically high. Calling these outliers is easy, but how can we ensure that all other measures are exact? So you see that the combination of the external data sources and the survey data was quite difficult, but we thought, how can we still generate value for GIZ?
Thanks, Rega. Summing everything up, we identified that the bottleneck of our work would really be the link which we wanted to establish between independent variables like soil and weather variables and the dependent variable, which is the land productivity, which we wanted to get from the survey data. Out of this reason, so we figured now this exact link has to be established by another source. For example, in the form of future surveys, studies conducted in other areas, or expert knowledge. Nevertheless, we felt that with our work, we came a long way, and we still wanted to utilize our work in the most useful way. In discussions with our respondents from GIZ and Komako, we learned that the external data, the soil and weather data we've been using, actually has not been known, especially not been used before. Thus, we thought our way of contributing would be rather to shift the focus of the project and focus on making this data available in an accessible manner to the experts from GIZ and Komako, thus rather paving the way for future work. And we did that by implementing our data in a Tableau dashboard, which I'm now gonna run you through in the next minute. As you can see here on the left, we're having a map of Eastern Zambia. And on the right hand, we're having a histogram over different soil properties. We can select from different soil properties in different depths, actually. For example, let's say we go for sand in 60 to 100 centimeters depths. As you see, the distributions, they update also on the left and on the right-hand side. And now we're especially interested in areas which actually show a lot of sand in the ground. And we directly see, we find that in the northeast of Zambia. While on the other hand, if we're interested in areas where there is actually very little sand in the ground, we rather find that in the south of the eastern province. This dashboard is fully customizable, so there are also other features you can filter for. Here we implemented a filter for the different geographical regions within Eastern Zambia, which is the valley and the plateau region. But let's keep that for all now. And we also implemented the same for weather data, which has a more coarse resolution, as you can say here, but I see here. Here we paid special attention to the temporal aspect of the data, so you can actually go back up to 40 years and see what the weather was like up to 40 years ago. And with that, I want to already come to our final conclusion now. And I want to stress 3 different points here. First of all, machine learning models are no silver bullet. They're not going to solve your problem in some kind of magical way. You're always limited by your data quality, and you cannot find what is not in your data. Thus, data collection is a crucial process of the whole data science modeling part. In our cases, would result in more consistent surveys over the next future years. Second, we learned that insights which you obtain from analyzing past surveys can guide you the next year, allowing you to shed light on aspects you've learned from the past surveys. Nevertheless, still a crucial part, this has to be in accordance with the first part, that you wanna keep the surveys consistent over all of the years. And last but not least, with our dashboard, we're able to provide fast and easy access to weather and soil data, which now can be combined with expert knowledge from other sources for fast data insights. And then hopefully, in turn, this will lead to actions which allow for an early warning system, for example. And with that, I want to conclude our presentation and thank you for your attention.
Yeah, great job. So again, if you have any questions, feel free to just unmute and ask. Or if you're somewhere where you cannot really ask a question, you can also write them in the chat and I can ask them for you if you prefer.
I have a question. I was wondering, how did you predict that there was a flash flood at a certain time?
Yes, I'm going to answer that. So there are various ways you could do that. At the moment, we implemented the easiest solution where we just looked at the time frame of 24 hours and then looked at the rainfall in that time. And every time a threshold is reached during this time, then we will note this as a flood event. And then we count the flood events in this growing season. And then this is how we retrieve this this number. Of course, there are other more complicated ways we could do this. Also looking at into the soil, like how wet the soil already is, for example. This is actually something that we're probably going to implement in this remaining week, since this is a very basic assumption that we're making with those 24 hours. But this is also being used in practice, we have to say. So yeah, thank you for your question. Is that answering it?
Yeah, thank you.
Okay, thanks.
In general, if right now you're overwhelmed by the presentation and the questions pop up in 5 minutes, you'll have plenty of time in WonderMe to go to the team and ask them and maybe challenge them even more and their assumptions. And yeah, really
maybe
see
I
how
would
that's
have one
going.
more question.
Okay, perfect.
So you said that kind of via analyzing the different interviews, kind of you could not really get something useful, or let's say not really a correlation between the interviews and the target variables. So if you would assume that you could design the perfect survey and you could carry it out all standardized, would you expect to get much more insights?
Okay, wonderful. Thanks for your question, Jaco. As we've seen on this slide, Rika presented. We don't present our screen anymore. We still have it here. There are like several aspects going into this. So like the point you addressed is certainly a really important point, like design the surveys in the way that they allow to explain this internal variation. But we saw these other 2 points, which also hindered us from like perfectly modeling the data, which was also, for example, the accuracy of GPS coordinates as well. So like, as you say, as you addressed, like this is a really important point there, but it's not going to bring us all the way there.
If I might add something else, there is research from other countries and investigating other sources of survey data, which is panel data, so over many years. And at least in those publications, there seems to be some predictive power in this survey data. So we would expect to be this to be the case in in Zambia as well. So I think if we have data on a longer time frame and also more accurate production data, then we would be able to explain more in this direction.
Okay, then I think there's also a raised hand, Michael, or is that left over from before?
Yeah, no, I raised it again. Thanks for giving me the room. Thanks for the presentation. Very interesting. We were very much looking forward what you will find, and also a little bit excited and about your assessment of the data. I see that the data quality is not too high. To some extent, we maybe have expected something like that, but it's still very interesting to learn that when it comes to the overlap over the years regarding these different survey rounds. I learned that in terms of the variables you then identified, you had only 40 left over, and to me then it seems that these 40 variables which you can find in each survey round are not very relevant to answer the questions you were looking for. And is it that you also by combining these different years you had a loss in power because you said something about too little observations at the end you could use? These were like two follow-up questions, and then maybe when it comes to the external data question, which is similarly to the one which has been asked before, you probably have some additional external data sources in mind which would be ideal to add to the exercise, but which were not available. Maybe you have something in mind here. In a perfect world, what would you add? And whether you have done or looked for some correlation between these external observations or external data and the actual productivity you observe in the surveys. Many thanks.
Okay, thanks for your questions. So regarding the questions for the survey, the intersection of the questionnaires in the years were also that small because we had a very different level of detail. For example, in one year we had like a very detailed question about the crop rotation. What crop did you grow on which field for every field the farmer has? But then in another year it was only, do you practice crop rotation? And we don't really know to which extent they do that. So that resulted in this only 40 columns left, and these 40 columns were not really that well to explain the variation because they were on a very aggregated level and not that detailed anymore. And maybe the question regarding the external data sources, Chris, Caro?
Maybe I can do that. So you said in the perfect world, what could we use? I mean, in the perfect world, probably there would be a nice network of meteorological weather stations across the country where you get the actual data of the weather that really happened in reality, because we have to, because in Zambia there is only very limited weather stations, I think less than 10 over the whole country. So we have to use simulated weather data basically. So we cannot be 100% certain how accurate this data source is. So perhaps if we could have everything, then we would like to have real data, like measured data from weather stations across the country, or at least the eastern part of the region that we're looking at.
But perhaps to even add to that, I feel like the reanalysis data we've been used, like if we now move away a little bit away from this perfect world situation, I feel the data we've been using so far is really just like as good as it will get. Like Vincent and I guess also you've already done a great job identifying those sources in the beginning. We also had a quick search for other sources, but like actually in the end it turned out that the only ones we ended up using, so solidgrid.org and ERA5, are actually like the best available ones out there. Especially ERA5 is kind of the standard you're currently using for reanalysis data. So from a little bit environmental science background.
Okay, thanks for us answering the questions and also for the presentation in general, and especially also asking the questions. We would now move onwards to the next exciting presentation, which is from the team working with Rega. Please share your screen. Perfect.
Hello, everyone. I would like you to imagine that you work at Rega, the Swiss Air Rescue, and you have just received a call that your friend has had an accident and they need to be rescued by a helicopter. But which helicopter should you send? There are more than 10 helicopter bases in Switzerland, and if you send the wrong helicopter, they might not get there in time and something might happen to your friend. So how would you choose? Well, at Rega, there is a person with years of experience to make such decisions, but it is still a huge responsibility. So now the question is, can we use machine learning to help us with this decision? For this, we used Rega's data about historical missions from the last few years. Our main goal was to be able to predict how long it will take to fly from every helicopter base to a patient and to provide these predictions along with other statistics to the Rega dispatchers so that they can make more informed decisions. In addition to this, we obtained insights about what can cause these flights to take longer, and we also proposed where new bases could be built to improve this flight time to remote locations. There were actually multiple challenges that we faced along the way, with the main one being the amount of noise in the data. Since our data was collected under time pressure, often, for example, the provided landing times and locations were incorrect. And another big challenge was outlier removal. For example, you can see an outlier in the picture on the left where we can't reliably say what the helicopter was actually doing. But the most important pre-processing step for us was actually to split the flight time into two parts, which you can see on the picture on the right. And these are actually, the first part is the time until the helicopter reaches a 2-kilometer radius around the patient, which is the actual flight time. And then there is the time spent actually looking for the patient in this 2-kilometer radius. And as you can see from the picture, these time intervals turned out to have completely different distributions. And we are able to predict them separately much better than together, since they depend on different factors. And we have integrated our predictions into a JavaScript web application, which Christopher will now show you.
Okay, so what we basically did, we tried to build an interactive dashboard which has two features. One is the flight time prediction, Philip will be talking about in a minute, and the analysis of historical data. And the simple idea is that Rega can load in past missions, and based on these missions, a map and multiple plots are created. And maybe I should say here that the data I'm showing today is some random data, because of course this data is normally very sensitive as it includes patient information and so on. But the general idea is that you, so to say, load in your data and then a map is created. And this map is colored according to the following. So the idea is to split a flight into 3 parts or a rescue mission. The first part, time T1, the time it takes to arrive at the patient, the time the doctors spent at the patient, and the time back from the patient to the hospital. And now the idea is simply that, a map is created where normally a lot of points are green and you can detect outliers. And basically now Rega can maybe get more insights about what kind of outliers caused or what kind of missions caused these events. And another thing is you can filter for different kind of helicopters. So for example, Rega 2, which I just removed, would be the one serving the basal region. And then another thing we are doing is we are creating a plot showing how many missions happened at what part of the day and how many missions happened on average according to some time frames. And now you can not only filter for helicopters, but also for mission keywords. So at Rega, normally most missions are associated with some keyword. So now I could, for example, filter out Krankheit, and you can see that somehow changes the map. So the basic idea is simply this like historical tool is used to give Rega some input into historical missions and maybe even learn more about the data itself. And the next part is the prediction model Philip will be talking about now.
All right, let's now have a look at how our interactive flight time prediction tool can simplify and hopefully improve Rega's decision making in their everyday task of just organizing the rescue missions. And returning to the example Matusz mentioned in the beginning, just imagine your friend is having an accident and you call Rega for help. Then the call comes in at the Rega dispatch center in Zurich. That's where all the missions are coordinated. And then on average, such a call comes in 30 times a day. And the person at the dispatch center now quickly needs to decide which of the Rega helicopters get sent to you. And that's, of course, a decision that is of crucial importance for reaching the patient before it's too late. So as soon as you've communicated the position of your accident, that's where our tool comes in. So the mission coordinator selects the point on this map, just as it was done now, and our machine learning model now predicts the expected mission time from all helicopters, from all the helicopter bases to this accident location. And now this has been done, and what you see is the three bases that are highlighted are the ones for which this predicted time is the lowest. And in fact, sorry, for each helicopter base, you see not only the one prediction, but actually three different ones. And those are at the top prediction from a linear model that is trained on all the available data of past missions. And then second, what we call the physical model, and that's just taking the 2D distance and dividing it by some fixed flight velocity, which is also similar to what Rega currently does. And then third is a k-nearest neighbor approach that is it predicts by averaging over past missions that happened around that same area, if any of those are available. So why even three different predictions? As to be expected, the first one, our linear model, performs best when we evaluate it on the historical mission. But still, it might be of interest to have all three of them available here and actually put them to the test on real future missions, and then compare the results also in comparison to what is currently done with the physical model.
So until now, we have been modeling with the base locations provided by Rega. But another question we have asked is whether we can further reduce the flight time if we are allowed to choose alternative base locations. We try to answer this by minimizing the average distance between mission locations and the nearest base locations. To do this, we performed a k-medians algorithm, which is set to minimize the average Manhattan distance, or L1 distance, between data points and corresponding cluster centers. This is actually not exactly the same as Euclidean distances, but the results should already be very similar. Now, on this map, you can see it's covered by many small colored dots, which are the recorded mission locations during the past decade, and they are colored according to which cluster they belong to. Then you have these larger yellow spots, which are the actual base locations, as you have already seen. And finally, you have the large black circles, which are the optimal base locations, or the centers of each cluster. You might have noticed that there is a near one-to-one correspondence between these clusters and the actual base locations. And in addition, many of these bases, such as the ones in Geneva, in Zurich, and in Interlaken, these are already within or very close to the optimal range. This indicates that the current choice of base locations might already be very efficient. But despite that, there are also some bases that are quite far away from the optimal range. And in these cases, the black circles might serve as potential target locations if a new base is to be opened or some base is to be moved.
So this is what we have been working on for the past few weeks. And we hope that you like our product. And above all, we hope that it can be useful to these guys. Thanks.
Okay, thanks for the presentation. So then, same deal as always. If you have any questions, feel free to just unmute. I already see there's one question in the chat. Simon, would you prefer to unmute and ask it, or do you want me to read it?
Sure, I'm happy to go ahead. So 2 questions. First of all, thank you for the very nice presentation, very interesting, and also super cool visualizations. I have 2 questions, basically just on how this is taken further. The first is regarding uncertainty estimates. So do you currently also provide uncertainty estimates as to how sure the algorithm is, kind of in which time frame it would arrive for each of the algorithms? And the second question relates to the input data that you use. So from what I got from the presentation, at the moment you seem to use past patient pickup data. And I was just wondering whether you also included environmental data such as wind speed, visibility conditions, say fog, rainfall, etc.
So maybe I would answer the first question. So actually we use 3 different models exactly for this reason, so that we can have some kind of uncertainty estimate. And basically we compare the outputs of these 3 models, which also Rega can use to compare to their own prediction. And basically if all of these 3 models match, then we treat this as high certainty, and in other cases we treat it as low uncertainty. But also there would be of course different ways, but we didn't explore them so much. One way is for example, we are actually using one feature, which is kind of the relation of the flight path that the helicopter has to take to the straight line, because sometimes there are mountains that the helicopter has to avoid. So the helicopter doesn't basically fly straight, but has to somehow fly in a curved way. So there you could, for example, vary this parameter, and you could basically, for the optimistic estimate, say that it is flying like more straight, and for the pessimistic estimate, you could say that it's flying like more in a curved trajectory.
Yeah, maybe as for the weather data, that's I think a good idea, and we also had that idea. However, it did not seem to improve our model much, and maybe there's 2 reasons I can tell you now. Which the first one would be that just our weather data, what we had was not like the best quality, but that part of course could be fixed. But the second reason is also that as we told you, we split the flight path actually into 2 sections, and the first one is just to get to the patient, and the second one is then within a 2-kilometer radius to actually find the patient and so on. And I would guess that the weather would have a larger impact on the second part, and then that part is hard to predict anyways. So just for flying alone, it doesn't seem to have a large impact.
Thank you.
Okay. Anybody else have any questions that they want to ask either through the chat or via voice?
If that's not the case, once again, either you realize just now that the question popped up, or you'll have time to also meet this team in WonderMe and get into a more detailed discussion, maybe also on the points. But until then, to have next is when I have the schedule, yes, is the IDMC team that should feel free to share their screen now. Maybe also unmute. I don't know if you're already trying to present.
Hello.
We can hear you now.
Yes. Super. Okay. Good. And you can also see my screen, yes? Perfect. Okay. Good. So we are the team from IDMC, and we developed a social media tool that helps to track people that are internally displaced globally. So when an earthquake happens, or a flood, or maybe a riot in a town, people have to leave their homes. And often they then go to the next town or the next region, so they often don't cross any country borders. So these people are internally displaced. And in 2019 alone, over 30 million people were internally displaced. And to get a better understanding of this number, within the time of this presentation, over 600 people are internally displaced on average. So this is a big humanitarian problem. And IDMC works on this problem. So they monitor how many people are internally displaced and why they are displaced. And then other organizations can use their numbers in order to plan sending help or sending food, for example. And for this monitoring, IDMC uses newspaper articles or official reports. And these articles and reports, they need some time to be published. And also in some countries, they are not very reliable or maybe even not existent. So for example, in countries with a corrupt government. So there's still some need to extend this source of information. And in these modern times, one source for information can be social media, and here explicitly Twitter. So people tweet all the time about basically everything, about politics, about funny things, and also about events that happen, and especially also bad events that happen. And the only thing that people need in order to tweet is a phone and internet, so it's very accessible to tweet. Also, it is not really dependent on any government, because every individual person can tweet. And if they tweet right away whilst a disaster is happening, which also happens quite a lot, then we are even able to get almost real-time data from tweets. So it seems to be a very potential data source to also use tweets for monitoring internal displacement. When we then look at all these information on Twitter, then we have to ask ourselves, like, what is actually important? So which are the tweets that actually talk about internally displaced people, and what exactly do they talk about? And for this, we developed a tool. And this tool first extracts tweets from Twitter. So here's one example tweet. And in the first step, this tweet is then analyzed whether it actually talks about a natural disaster or a conflict somewhere on the planet. So in this case, this tweet talks about a flood. After this first step, the tweet text is pre-processed for the step then, and this step is to classify this tweet into relevant and irrelevant tweets. So the tweets that actually matter for internal displacement. And this tweet matters, so it is relevant. And then in the next step, we extract all the important information that can be useful for IDMC. So for example, in this case, so for example, in this place, who is affected by this flood? So it is families that are displaced. And how many families are displaced? There are hundreds of these families. And then these tweets might also contain a location or a time for when this event is happening. And for these information extraction, we use named entity recognizers that we trained on these special internal displacement data. So in this third step here, I said we classify these tweets into relevant and irrelevant parts. But how does that actually work? So for this part, we trained a classifier on 600 labeled English tweets that we got from IDMC. And in order to train this classifier, we first do a filtering. And in this filtering step, we filter if this tweet actually talks about internal displacement, so about a natural disaster or a conflict. We pre-process this text and embed this text into a more suitable embedding for these classifications. And then we train the classifiers on all this information. And with this training procedure, we are able to train a classification model that takes a tweet as input and then classifies this tweet into relevant or irrelevant with 80% of accuracy. So when we get a tweet, so for 80 out of 100 tweets, our model is able to decide correctly whether this tweet is relevant or irrelevant.
Okay, I will continue here. And we were thinking about how IDMC can actually benefit from our tool, and more specifically also from Twitter as a complementary data source to traditional sources like newspapers. And to understand this question better, we considered the global distribution of tweets posted. And clearly you can see from the map that there are certain hotspot regions, while other regions are have very little coverage. So this is an aspect where we cannot really do a lot because this is just a property of Twitter. Then another aspect is language. So English tweets are most often posted in the United States and certain other regions. But when we look at South America, for example, there are very little tweets in English. So we were wondering, how can we use our tool and also improve the coverage of tweets that we can extract and classify. So from the data set we received from IDMC, you can see here that lots of tweets are actually originate from the United States. And there are also some from India, and these cover certain events which happened during the time in September when they retrieved the tweets, and there were these California wildfires, for example, and some floods. So the training data set actually covers some very specific regions and events. This can also be shown in some other figures. So the first shows that around a third of the training data set originated from the United States. And the triggers for the displacement were mostly natural disasters, so floods and fires, while conflict has very little coverage in the training data. So this made us think that the training data set may not be very well representative of all global displacement events. So as I already said, we can increase the coverage of the of our tool if we include tweet translation. And we actually did this and tested it with Spanish tweets. So the tweets were translated, and then we applied the same model which was trained on the English tweets. What we received was a classification accuracy of 70%. Now, this is a bit lower than what we received for the English tweets. However, we still think that it's quite promising, because the tweets in Spanish actually also covered some very different topics. Many of these originated from Central America and South America, Colombia, Venezuela. And in these regions, we saw that there are very different displacement triggers, such as conflict, drugs, and like drug violence related stories. So actually, this result is still very promising, and we think that it can also help to really get additional information about displacement, not only coming from the United States, where there already may be a lot of data available from traditional sources. So to summarize, we have developed a tool that allows for IDMC to retrieve data from Twitter, classify tweets, whether they are relevant or irrelevant, and extract additional information which they can use for their analysis. So this is just quickly the team which has been working on this question for the last weeks, and we've had a lot of fun, and want to say thank you to the organizers and IDMC for providing us with this interesting challenge. So you can ask some questions.
All right, thanks a lot for the presentation. There's already one question in the chat. Matos, do you want to ask it yourself?
Yeah. So I have one question about evaluation. So actually you reported mostly accuracy actually on the training data, but I wonder, did you try actually verifying other metrics such as precision recall or the F1 score and so on, to see like how well the model would be basically to see like the false negatives and so on. So in real data, I guess that there could be a different distribution of these, like a class imbalance. So this could be quite interesting. Let's see.
Yes, so we not only considered accuracy, but also, yeah, as you said, for example, the recall, and they were all between 70 and 80%. And we mainly, so whilst training and deciding which model to go for, we mainly looked at the confusion matrix and always looked at true positive and yeah, all these different values basically, and try to consider yeah, that maybe the accuracy is not the only value we should look at. Yeah. And then also for the second part, I mean, what we actually trained on was real world data, right? So these were also tweets that were extracted, and then they just used some of the tweets that were extracted and labeled them, but there was not really like a choice that they made, but they just used like the first 600 tweets and labeled them basically.
Thanks.
Yeah, there's another question in the chat by Renato. How would you decide what?
Sorry, I believe it's my question, yeah. How would you decide what tweets to look at after all?
So maybe I can take over that question. So essentially, in the end, we ended up having a hard-coded rule that had a trigger term or a list of, we have a list of terms that we got from IDMC that are important to be included in the tweets. So this is our first step, is this hard-coded rule on when if we take this tweet or if we don't take it into account. We do not have certain accounts though that we monitor. So there is any individual or governmental or organizational account would be included in that, or tweet from these accounts.
Okay, thank you. The follow-up question would be, did you think about how you would deal with double reporting and also with updated tweets or updated statuses?
So we actually have not thought about the updated tweets. I don't know. I've never. Can you do that on Twitter? Actually update them?
Maybe what I mean is if someone reports something and the day later corrects what he reported.
Yeah, this is a very good concern. And so far we have not really thought about that, or how we can remove doubles. I mean, so for now, what our thought was to actually give as much information or to automatically extract as much information as possible. And then I think that there is someone necessary or some user necessary to look over that in the end, to include it in a final statistics, especially to remove those doubles, because you could get, I don't know, 200 different tweets on the same event. So you would get that 2,000 people being displaced there in this wildfire, and then the same wildfire 1,500. So I think there would need to have a way more complicated rule to work on this.
But I also think that also happens with the newspaper articles, for example. So they always give like updated numbers. Maybe a week later, they know more numbers. So I guess that's a common problem for this, to keep everything updated. So yes, I think it is important to deliver most of the information, or like as much information as we can get. Yes.
Okay, thank you.
So
maybe I.
Yep.
Yeah. Maybe I also have like one follow-up question now, if there is still time.
Yes.
So my question would be, have you also considered using the actual users of Twitter in the classification? I just like, it's just a thought that basically like similar users could share like similar kinds of tweets. So it is possible that, for example, the information could be like in the description of the user, basically, that they are like a serious person or a person that shares something unrelated or something like this. Maybe that could be useful, like to actually find out which profiles to scan. Did you explore something like this?
Yes. So the tool right now uses, for example, the verified status of the users as one input. However, that didn't make such a huge change in the accuracy than especially I expected there to be more improvement by that. But yeah, all this metadata, when we extract the tweets, can then also be used for the classification. So right now it is mainly focused on the text, but then some meta information is already in there, and also more can be included in the future if that seems to also improve. I mean, in the end, it comes down to this that we had these 600 tweets. So when we then have a like larger set of tweets, then it also would make sense to include even like more attributes and more features, and then then we will see if that improves the model.
Okay, thanks. So I would, I think there was one question in the chat, but then there was already the follow-up discussion. So Tim, has your question been solved, or you want to raise it? Then you will need to unmute.
It's solved.
Okay, perfect.
No, it's
okay. Then I would announce the next team, and that is also the last big presentation of the teams today. And that would be the team working for and with Helvetas.
To all the audiences present here today, have you ever considered the answer to these questions? How much data is being created every day? Let me tell you, there is estimated 2.5 quintillion bytes of data produced by humans every day. And for your information, 1 quintillion, there is 18 zeros in it. And how much data is being used? And how much of those data has been used for a good purpose? Maybe we don't know the exact answers to the last two questions, but here we are the Helvetas team. We are in collaboration with the Swiss NGO Helvetas to use data analytics to create impact. In 2019, the Swiss NGO Helvetas spent 1.09 billion Swiss francs to help shape a better life for over 3 million people around the globe. And 30 million Swiss francs of the incomes of those expenditures are actually come from fundraising. And here rises enticing and concerning questions for most of the NGOs, including Helvetas. Where are the donations coming from? To answer that questions, we are here combining our knowledge in data analytics to striving to understand the demographic information of the Helvetas donors and to figure out who is behind those donations in order to strategize the precise and targeted marketing for the NGOs. For example, there are observed generational differences in terms of donating, and the baby boomers, the generation who was born within 14 years after the World War II, they are taking the leading roles in terms of percentages of total giving of donations, followed by reconstructors, Generation X, millennials, and Generation Z. To form a better understanding of the age distribution of the donors, we are able to predict the sustainability and the continuity of the future donations. More precisely, we are in particularly interested in answering this question: how old are the Helvetas donors? With the Helvetas database, we have access to 90,000 donors with their informations of their characteristics. And of course, the most important feature, the age. However, we're still lacking understanding and information of the age for the rest of 270,000 donors. And here comes the most exciting part. How can we infer the age information from the data and the resources we have in hand?
So to get started, I suggest that we first look at the data that we actually do have. So here on the left, you see the age structure of the Helvetas donors for which we know the birth year, and on the right, just the population pyramid of Switzerland. So if we compare these two plots, we see some striking differences. Well, the first one is that actually for the Helvetas donors, the birth years 2000 to 2020 are practically empty. But that's not too surprising because these are children and youth, and they tend to not donate. A second striking feature, however, is that the birth years 1980 to 2000 seem to be overrepresented. And this becomes especially clear when we put these two plots onto each other. So we have to wonder, why is this the case? And if you're an optimist, you might now say, well, maybe young adults are just especially generous when it comes to donating to Helvetas. But, well, unfortunately, we have some evidence that this might not be the case. So if you look to the right plot, what we show you here is the share of labeled entries depending on the year that the entry was added to the Helvetas database. And it's quite obvious that for older entries, the chances that they had a birth year attached is much lower than for the newer ones. And in turn, that means that it is very likely that actually among our donors, there are much more older people and we just don't know about them yet. And this, in fact, is why we really have to do some modeling here. So why am I now showing you this very colorful map of Switzerland? So first, obviously, because it just looks fancy. But second, we can also learn something from it. So what you see here is the relative number of donors for Helvetas across Switzerland. And what we see is that actually, while there are some regions, for example, around Zurich, where already many people are donating from Helvetas, there are already also some darker spots on the map. For example, in the southwest, So what that means is it might be worth making some targeted marketing there. But let's come back to our main question. That means, how old are the donors? And if you look on the map on the right, you see that actually across Switzerland, the average age of people differs quite a lot depending on where they live. And that is why we combined the known geographic information about our donors with the age information about Switzerland to enhance our dataset. One other interesting piece of information we have about our donors is their first name. So how can we relate this to age? Well, just imagine you're meeting two people, and one is called Hans and the other one is called Julia. I bet that all of you would first assume that Hans is older than Julia. Well, and it turns out that your intuition is actually reasonable, because the average Hans in Switzerland was born in 1951, whereas the average Julia is a kid of the 90s. And it turns out that there are striking differences like this for many first names. And that is why we also incorporated this data in our dataset to enhance it. And well, now let's see what we can do with all of this information in our modeling.
Great. So as my colleagues have told you, the end goal of this project is to understand the age distribution of donors, which means predicting the missing age of about 2/3 of the Helvetas donors. Therefore, we have implemented multiple machine learning models that learn from data and that allow us to complete this task. As you can see in the slide, the table in the left shows the model name and the mean absolute error, which is a metric of prediction accuracy. The results show that random forests perform the best with a mean absolute error of around 8 years. Moreover, on the right side, you can see the age distribution of the whole data set, which we created with the predictions of our model. And what you can see is that we can actually predict more old donors. And given that our data set is biased towards young donors, as Stephanie has shown, this is very reassuring and probably means that we did a good job. So we know that the model is not perfect, but we are quite happy with the results, and we are confident that Helvetas will be able to take advantage of it to improve how to approach potential new donors. Now, another important question is, what features matter? In other words, what are the features that help us predict the age the most? So the bar plot answers exactly this. In this plot, the x-axis shows the features names, and the y-axis shows the gene impurity, which, without going too much into detail, represents how important a feature is with a number between 0 and 1. So there are multiple insights from this graph, but I will focus only on two. First is that the name of the donors is a very important feature to predict the age. The first two bars are related to the name, and combined, they account for almost 50% of the variation in age, which is quite a lot. The second interesting insight is that the bar rest, which includes many variables, doesn't matter that much compared to the other ones. Specifically, neither income per capita nor education level play an important role in predicting the age, which we thought it was very surprising. Finally, I just want to say that for us, it's really important to deliver something that works, and that's something that is reproducible, so Helvetas can take advantage of it in the future. And that's why we have implemented all our work in two frameworks, Kedro and MLflow, which makes everything super easy to use and very robust. And now my colleague Cecilia is going to give you a demo of how these two frameworks work.
Okay, great. So let's go into the demo. One of the nice tools of Kedro that Rodrigo has told us about is a framework to make machine learning models more reproducible, is that we can visualize our pipeline. Let's see. Here we have the full workflow. And in the first part, you can see the data engineering part. In the first row, we will have all the external data sets, the education, the names, the income data, and the Helvetas dataset. After some cleaning, we will merge them here to obtain an enhanced dataset that after some transformation, we would like to fit into our model.
For that, we go to the data science part of our pipeline. That's quite standard. We will split our data into training and test. We will train the model to finally predict the birth year for the donors. So you will get a data set with the ID of the donor and his or her birth year. So cool, this plot is really cool, but how can you really use our pipeline on new data? We have also tried to do that in a quite straightforward way. So we have implemented our model in the format of a Python library. What is the advantage of this? That you can just install it as any other Python library with pip install and the name of this file. And with just this one line of code, it will take care of every dependency, every package that we have used, and you will be ready to use it. For run it, you just have to tell Python that you want to run our pipeline that we have called Helvetas Hack4Good. We press enter, and the pipeline is running. In the interest of time, we are not going to wait for it to finish, but I would like to show you a last tool that we have used in our pipeline, that is MLflow. MLflow allows us to track our machine learning models in this kind of dashboard, where we have every run of the model with every parameter that we have used. For example, here you have the model name and the metrics. That is the performance of the model, how well that model was doing. This is really cool because we can really easily compare different models. For example, the random forest with just one of these models that's based on linear regression. Look at the different metrics and also play around with the parameters. The most important thing about this is that this makes our model
You're
entirely
running over
reproducible.
time, so it would be good if you come to an end.
Yeah. So we will just finish with the 3 takeaway messages from our work. First is that we have some interesting insights about the database with the external data. Second, we have developed a machine learning model that recovers all these old donors in the database. And finally, we have a final product that is easy to install, to use, and highly reproducible. So we would like to thank you all for listening, for Hack4Good and Helvetas for this project, and our mentors, Jacob and Lionel, that has worked a lot with us in this project.
All right, great presentation. Thanks a lot. Lots of congratulations and great works in the chat. Anybody have any questions that they want to ask, either like through the chat or also just unmute yourself?
I have a question.
Sure, go ahead.
Yeah, first of all, thank you very much for the very interesting presentation. And this is the candy for you guys, the virtual candies. And I have 2 questions. So the first question is more about the operational process. So I saw like you use the casual as a pipeline implementation. I'm very curious about what kind of like challenges do you face when you implement the casual during this project? And also the following question would be, how do you think the casual improve the performance in general for your projects? Like what parts you think is quite beneficial and what parts you think it could be improved? Thank you.
Okay, I think I can answer that. Thank you for your question. Maybe the hard part is like always just the beginning, because you have to go into this new framework of thinking the pipeline and how is it organized. But once we get the feeling of how it was working, I think one of the better advantage was at the moment of coding the models. It was really easy to just split the work and do it really in modules that then we can just combine and everything work. It's really easy to extend and very flexible.
Mm-hmm. But do you have like any maybe the issues when you try to combine the pipeline with the new model, for example? Do you have to implement many or implement libraries or new features when you try to like update the models, like updating process?
I think that's the nice part. Like we can talk about it later more in detail if you are interested. But for example, we have the training function, and you will have all the parameters in an external file that you can modify. So we just have a training function and the different model in different functions, and we call with the model name. It will automatically call that function, and you don't have to go into the code to modify what are you using.
Thank you. Yeah.
Anybody else have any questions that they want to ask about the presentation?
Maybe I can go with a last question. So the names matter, and the age matters, and the geographical location matters. Education not, the income not much, and so on. Have you thought of any additional alternative explanations of what other factors might matter in the future, just for the sake of curiosity? I feel also to your no.
So, yeah, I mean, you're like asking about like the amount of donations in the future. So I think we have to admit that we didn't get much into the like thing of really predicting the future yet. So I would rather answer with no. So we tried some things to find correlations, and yeah, so the results that Rodrigo presented, but not much more, especially not when it comes to the real like time prediction part.
And just to build upon that, I really find it impressive how you extrapolated information based on names, and also I don't know whether you only looked, to my understanding, you only looked in your sample how old were people with the same name, but in general there's a wave of giving names to kids. So if you could also, I've thought maybe you're looking at the trend of giving names.
Yeah, well, actually we use like data from the Swiss Statistical Office. So it's really the average Hans in Switzerland and not the average Helvetas Hans.
Okay, no, that was for clarification, but really cool, interesting and insight. Thank you for sharing that.
So once again, and now you don't even have to wait so much. If any question pops up in a second, then you'll have a lot of time and WonderMe to actually go for it. In general, I wanted to spend a few minutes or a few seconds actually on discussing how we go from here now. So I think in this meeting there are a few students who probably were asked by their friends or so on social media about our event. So if you're interested, also the participants interested in being organizers, David is sharing the Google Forms link for sign up. You can again discuss also how you can help in WonderMe. For non-profit representatives, it would also be really great if you stayed to the WonderMe that I'll introduce in a second, because there we can discuss best. However, you can also schedule a meeting through the Calendly link that David just shared, or write him an email right in the chat right now. But it would be really great if you stayed around for WonderMe, because that's what I'm going to introduce now. And I think that's something we have really missed and still missing in these times of pandemics, this fun after event part. And I think that we can make it work in the following way. So you'll get the WonderMe link in the chat now. Don't click on it just now, because then you'll probably be gone, and I wanted to give a short introduction. So in general, when you click on the link, something like an application or sign up form pops up, where you just enter your name, possibly in brackets your affiliation, if you want to share that. then you accept that. Then you're going to get to this window where it would be helpful if you allowed your computer or your browser the access to your microphone and possibly even to your camera, because then video chatting and meet and greet is a little more interactive when you can actually talk and be seen. Next, it is possibly helpful if you click on this small zoom out button, because then you will be able to see our whole meeting room and our whole conference area, to say that. And for the beginning, what we would like to do is that the NGOs and the teams working with the nonprofits have some time to be in their individual rooms that you can see here. There's a food security, GIZ, there's a survey impact. So people from the teams and the nonprofits that are already our partners move around, which is possible through the arrow keys or clicking where you want to go, and move to your respective room. And there, the NGO responsibles from Hack4Good will collect you in one circle, and everything will be settled. For all the others, also, please stay around. I think it's really interesting for us to see your motivation of joining the event, what you thought about the event, what you would like to see in the future, learn more about the Analytics Club, SPH, everything. You can ask us anything. It would be great if you came to the welcome desk by moving around, and there some NGO organizers will collect you also, join their circles, and there we can discuss what are your motivations, what are your interests, and that only a few minutes. Before then you can spread out and go to the NGOs and go to the teams, to the representatives, meet everyone in their respective rooms and just go there and talk to them. And then we have it really, really nice and interactive. And maybe you can set yourself some goals, being in at least 3 rooms at some point, having talked to a few people, having done the full circle 3 to 4 times, I don't know. You can also be ambitious. But it would be really great if you gave this tool some time. If you had any questions, there's also a chat function, like maybe if your walking around doesn't work or the joining of circles doesn't work great, you can click on this symbol, on this speech symbol, and then a chat opens and you can write to everyone. And one of the organizers, if he or she sees the message and can identify your avatar on the screen, will quickly walk to you and engage you in a video or voice chat, and can solve any question to WonderMe or any other question you might have. So, quick summary: everyone who's not participant of Hack4Good, go to the welcome desk and be welcomed. For the teams and the nonprofits already working, go to your rooms. And now the link should be shared. And yeah, I will click on it now. I'll still be in the Zoom meeting, but yeah, hopefully meet you all there.